Assalamualaikum and good evening to Dr. Fatiha. This is our group presentation, techniques of differentiation. This is our topic, and we also from group 6, and this is our group member containing only 2, and my name is Muhammad Azikman bin Muhammad Osman. 2025 102771 is my student ID. And we go to introduction. Introduction is about question 1, that's to explain meaning of differentiation. Differentiation is a fundamental concept in calculus that measures how a function changes as its input change. Rate of change of the slope at a curve at any point. This means dy dx is very important to know rate of change of the slope. If we see, we have a function y equals to fx, and we derivative it, become dy dx, show that how fast y changes when x is changed. On graph, it gives the gradient of the tangent line at specific point. And if you look at the below, we have a few example how dy dx used in our real life. And we go to the next. The next is question 2. We need to find the differentiation of y equals to x cubed e power tan 2x, and we look at here, we need to divide it into two functions first, at two group, which means u equals to x cubed, v equals to e power tan 2x. So step 1, we need to differentiate the x cube first. We need to use power rule. If you see here, use power rule, and we see here the formula, and we use it as n is a value, and we bring forward into 2 in forward to x, and the value of n we need to minus it with 1, so we can get here 3x power 3 minus 1, so the final value is 3x cubed. The step 2, we need to differentiate the second the second function. We need to use chain rule two times. So this is, we need to know it. We have two product here, tan 2x. We have tan 2x, the first product, and the second product in a bracket here is 2x. So if we if we see here, we multiply it, divide by them. So tan 2x, we have differentiated, become sec 2 in bracket 2x times 2. So we have a v prime here, 2e tan 2x sec 2 in bracket 2x. Step 3, we need to apply product rule. This means u prime v plus uv prime. We take it all of this value into the formula, and we can get the formula here, 3x cubed e tan 2x plus 2x cubed e tan power tan 3x cubed e power tan 2x sec square 2x. If we see here, the both of side have a same value, x cubed and tan 2x, so we remove it from the bracket and bring it into the in front of bracket, and we can get the final value 3x cubed e tan 2x, the in bracket 3 plus 2x sec 2 in bracket 2x. We move to the next question. We need to differentiate this equation, so we do the same thing. We need to divide it into two group, u and v. The u is ln sin x, the v x cubed plus 5 in bracket negative in bracket power negative 1 over 2. The step 1, we do the same thing also. We need to differentiate it, and ln sin x become 1 over sin x and cos x, because they have a two product here, ln sin x and sin x. If we differentiate both of them, we can get the cot x, because cot x is equals to cos x equals sin x. Step 2, we need to differentiate the value of v. V also, we have a two product here, x cubed plus 5 negative power negative 1 over 2, and in bracket x cubed plus 5. There's two product and if we differentiate both of them and multiply it, we can get negative 3x cubed over 2 in bracket x cubed plus 5 negative 3 over 2. We apply product rule same with before using all of this answer, and we can get the final answer cot x over square root x cubed plus 5 negative 3x ln sin x over 2 in bracket x cubed plus 5 in bracket x cubed plus 5 power negative 3 over 2.
Hello, my name is MAT183. My student ID is 20255079991, and I'll be continuing the presentation. On question 3, we are given exponential to the power of xy plus ln x plus y equals to sine xy plus x cubed, and we are asked to find the dy dx using implicit differentiation. So in this question, we have to differentiate x in terms of y. So by differentiating exponent x to the power of xy, we get exponent xy times y plus x dy dx. We get the x times dy dx because we are differentiating x in terms of y, hence why we are getting the dy dx after differentiating x and not getting the dy dx after differentiating y. After that, we differentiate the ln x plus y, and same cases just before, we get, by differentiating the ln x, we get 1 over x plus y, and then in brackets differentiating y, we get the dy dx, and getting 1 is from differentiating the x. And then next up, on the other side, we are going to differentiate the sine xy. Derivatives of sine is cos, and then we still have to multiply inside the bracket. So we also get the y plus x dy dx just as the exponential one. It's quite the same. And then by differentiating x cubed, we get the 3x squared. After that, we rearrange everything with the dy dx on one side, and then expanding the equation by multiplying inside, and then we get everything, and just combine every dy dx together on the left side and the non-dy dx to the right side. After factorizing the dy dx, we can rearrange the equation, and this is the answer we got. Continuing to question 4, we are given ln 1.02 minus 2 over root 5 1.02, and then we are asked to find to solve the equation using linear approximation. First up, we have to identify the given value. The given value is the one with the decimal points, the 1.02, and then we have to change it to a new number with a new round number, which is closest to the 1.02, which is 1, and then we find the difference between the two, hence delta x 1.02 minus 1, and then by writing out the equation using in terms of x, because we need to find the derivative of fx, which is f prime x. So in this given question, we have to use quotient rule since it's a fraction. So by separating the uv and using the quotient rule formula, the dy dx equals to v u prime minus u v prime over v square. We get the equation for f prime x, and then after that we just insert the value of the new value that we gave, which is 1, into the equation to the fx and the f prime x. After inserting the value, we have to insert it into a formula for finding the linear approximation, which is fx equals to fx naught plus f prime x naught times the difference, the delta x, and the answer needs us to give it in 3 decimal places, so we get the answer negative 1.972.
Okay, now we're moving to conclusion. In conclusion, differentiation helps us to understand how a quantity changes with respect to another. It shows the rate of changes of a function and represents the gradient of the tangent line on a graph at a specific point. Through the differentiation, we can measure how fast or slow changes occur in real-life situations such as speed, height of yield, and population growth. Therefore, differentiation is an important tool in calculus that connects mathematical concept to real world application and help us to analyze change more clearly and accurately. That's all from us. Thank you.